looking at approximations of numbers. Approximation is another word for rounding off numbers to certain places, which are either to the significant figures, to decimal places, or to nearest whole number. So usually questions come, and questions is phrased to round off numbers or approximate numbers to the nearest whole number, or to the nearest decimal places, or to nearest significant figure. So we have to understand what they are referring to when they say round off number to the nearest significant figures, or round off numbers to the nearest whole number, or to the certain decimal places and all that. By understanding the definition for each of these character here. First, we will look at significant figures. Now, what do we mean by the word significant figures? Now, a significant figure is just a number that is relevant in a place value. Okay. Whenever you are going to describe a number, any number that is relevant in describing that number is significant. For instance, if I'm going to say 100, the two zeros here are very significant, because if I do away with any of them, it will affect the description for this number. This number is called 100. Now, if I take away one of the zeros, probably take away this one, it becomes 10. You see, it has affected the number to 110, or what you call a single 10. So this zero is important for this number to be called 100. Usually the controversy is with zero. Most times we find it very difficult trying to know where a zero is significant and where it's not. Now I'm going to quickly look at this properly. Let me take this out. See how zero becomes relevant to the description for a number. If, for example, I have 0, 0, 3, 0, 6.02. Alright, we take this number 00306.02, and the way this number is pronounced is 300 and 6.02. okay, 306.02. Now the idea here is that the number is split into two parts. The first part is called your whole part. This is the whole part, that is the number before your decimal point. This is where you have your decimal point, and this other number after your decimal point, which is called the decimal parts. So you have whole parts and your decimal point. Now if I'm going to call this number, if I'm going to describe this number, I will begin by describing the value of the whole, which is 306. But the number didn't just end here. You have a lot of them here. You have other numbers 00, but they didn't take part in the description. The reason is because they are not relevant, they are not significant. Although they represent a place value, like 6 is under units, this 0 is under tenths, and this 0 is under 100, this one is under 1000, and this is under 10,000. But they did not take part in the description of this number, so they are not relevant 0. Why this other 0 took part in the description, in the sense that if you remove the 0, it becomes just 36, so you can't do away with the 0. For you to be able to call the number 306, it's the 0 here has to be there. So in a nutshell, what are we talking about? Any 0 that comes before a whole number, listen, is not significant. Why? If a 0 comes in between two numbers, two significant numbers, then the zero is significant. That is exactly what we are establishing here. So this one is significant because it's coming in between two numbers. Now let's go back to the decimal part. Like we said, 306.02. It is very different from 306.2. This is 306.2. Now that is a very different number entirely. This is 306.02. Now 02 is a fraction that represents 2 over 10 over 100. Sorry, the O2 part is the 2 over 100, while this other part is just 2 over 10. So there are two different values here. Now what did you notice here? You find out that the 0 comes in between numbers as well, because the whole of this number is what characterizes this value. You cannot do without it. So the 0 is also in between numbers, okay, in all of this. So it comes in between all these numbers and all that. So it's still very significant. So any 0 that comes in between numbers is significant, whether on the whole part or on the decimal part. Now how is it taken? We are going to quickly look at how it's taken. We'll write this value 306.02. We are actually focusing on this part, which is the decimal part. Now you can see that your place value is taken from this direction, this way to the left, while this other one is taken from the decimal point down to the right. Okay, now it makes a domain. The whole of this from here down to this point is a domain. This is called a domain. So what we are having is that any 0 that comes in between a domain is very, very significant. But what if it's outside the domain? It's not significant. Let's see an example. If we have 0.00640. Now let's see the zeros that are significant here. As a matter of fact, the domain lies from this point down. Why? This 0 shows you your place value, like it is here. There is no number binding here. There's no number binding from this end. So if you look at this very point here, no number is binding until you get to this point. So here there's no number, okay, down to this point, and this other points to this point because it's taken to this direction. It doesn't have a number. It started binding from here to here. So where the binding starts is where you take your decimal point. And remember, these other zeros come after decimal points. So any 0 that comes after decimal point is actually not relevant. So the significant figures we are talking about here is just 64, although these ones help to explain the place value, so you can't do without them. So if we're taking another example, let's say we have this example. Zero, 4, 2, 6, 0, 1, 3. Now let us see the significant figures here. These are just whole numbers because it doesn't have a decimal point. So we take our units first because the number starts from here and starts graduating towards this place value to the right and to the left, sorry. So my domain would be between 4 down to 3, because any 0 that comes before a digit number is actually not important because it does not take part in describing this number. So this is not a significant figure. So here we have 4, 2, 6, 0, 1, 3. Now again, this 0 that comes in between is significant because it's in between the domain. So this is the domain. So what we are trying to say is that any 0 that comes in between a number is very significant. But what about if it is on the decimal part? Say for example you have Say for example, you have 3.02800. Now this is the same as 3.028, because this other 20 they come after a closed domain. Remember I told you a domain is a digit between 0 and 9. So any number that is between 0 and 9 forms a domain. Now I said any 0 that comes after a domain, before after a domain boundary, is not significant. So this 0 comes after, so they are not significant. Here we are going to take our domain from this point down to this point, which is represented here. So the zeros that comes afterward is not significant. In a nutshell, any other 0 that come after a decimal point and it's not closed by a number. Remember, this is not closed by a number. It's just keep 0 0. You can keep writing it as much as you want. As long as it's not closed by a number, they are all not significant. So these are not significant. So they are not significant zeros because they are coming after the decimal point and is not closed by a number. What do we really mean by significant figures? We are going to see a definition here proper that says a digit is significant if the digit must be present before a complete description of that number is obtained. So that is just the definition for a significant figure. Now we may want to take a look at so many other ones. Significant figure using the concept of domain. What is a domain? A domain exists between numbers that are closed by integers. Now let's say for example we have numbers like 0, 3, 4, 0.02400. Now what you do is zeros don't close a domain. It is an integer that closes up a domain. So for you to get a domain, look at the first integer here and look at the last integer here. Then any number that exists between them is the number within that domain. So this is called a domain. Now every other 0 that appears outside the domain is not significant. Now this is not significant. How do we trace the values that are not significant here? This 0 is not significant, this one is not significant, and this is not significant. So the significant values will be 340.024. So these are the significant figures within this domain. Now if I'm asked to approximate to 3 significant figures, for example, maybe the question here says approximate to 3 significant figures. Now I'll start counting here. I have my first number 1, 2, 3. Then I'll take a rule. This is going to be my boundary, although it's taken at the very decimal point. That's going to be my boundary. So I have this whole part that I need. Then this one will be the rounding off number, which is the very next number after my boundary. And remember, the number is not between, if the number is between 5 and 9, you call it 1 and add to the next value. But if the number is less than, you can discard it. But in this case, it can be discarded because it's not up to. So my answer to this question now becomes 340.000. Now once again, every other 0 that comes after a decimal point is not significant. So I have my final answer to be 340. That is what I'm having. Now we can take another example. Supposing we are given another example here, and this time around we say find the significant figures in 0.00036680. Now, here again, I'm going to list out the number. The solution first will be, I'm going to list out the number which is 0.1230366680. My domain lies within this point here, which means all these values are not significant, although we cannot discard all these zero here. They are helping you define the place value of these numbers, so you cannot do without them. The only thing is that you can discard this other one. So what we are trying to say is this one will be relevant in course. So we are having our significant figure to be the whole of this, which I may just represent in a highlight, 0.000. Then my significant figure will become, you have 3668. These are actually my significant figures, but it's not proper for me to discard these other zeros, because the other zeros there only help us show the place value of those numbers. That's the reason why I will not discard them. I will still have them there, just there for formality, but they are not significant. We are going to take an example. The question here says approximate (0.005762) to 3 significant figures. My solution would be, first I'll bring the numbers out. 0.00, there's a point here, 5762, and these are my significant figures here where I have my domain. So I'll list them out 1, 2, 3, which means I'm going to have my boundary on this point. The value is not up to 5. I'll discard it, and it becomes 0.00576. Although this is supposed to be a 0, but I can forget about it because it comes after a decimal point. So take note of that. The zeros here are not significant, but they only help to describe the place value of all these significant figures. Let's look at a very important note here. We'll look at these notes. If we are rounding off whole numbers to significant figures, if we're rounding off whole numbers to significant figures, let's say for example we said 46283 to 3 significant figures. The solution here becomes our number is 462 46283 to 3 significant figures. So we're going to count our 3 significant figures, which is 1, 2, 3. I take my boundary. Now this is the number I need to round off, because the next number is what you're actually rounding off. This other one is too far to round off. It's just the next one close here that you round off. So this one you take it, if it is between 5 and 9, you call it 1 and add to this other number here, and it becomes 463. Okay, Now these other numbers will become 0, 0, but you cannot do away with them. The reason is because they are whole numbers, so they are defining the property of this number. If you do away with them, the number probably becomes 463, but if you leave them there, it becomes 46,300. So this is a two different number. The zeros here are defining the property of this number, so you cannot forget about them. So what that is saying is that whenever you are rounding off whole numbers, always include the 0 after you have rounded off the number to your significant figures. It is only when the zeros come after a decimal point that you can forget about it, like we had in the other case. We may want to look at another example. And this time around it says approximate approximate 5.0631 to 3 significant figures. So what we are having in our solution here would become, first I'll bring out the number 5.0631, and I'm going to approximate to 3 significant figures. Of course there's a closed boundary here, so this significant starts here and becomes 1, 2, 3, and I'll take my boundary. So this is what I'm rounding off, and it's not up to 5, it's not between 5 and 9, so I'll just forget about it because it's too small. And here I will have my approximation sign, and my answer becomes 5.06, then 0, 0. But these two zeros that come after a decimal point do not make sense, so they can be removed. You can forget about them, and you have your final answer to be 5.06. You see how it's done? The zeros after a decimal point can be discarded, while the zeros that are in the whole number will not be discarded because they are actually defining the property of that number. So we're going to look at the next case, which is decimal places. Alright, if we are rounding off values to decimal places, what we need to do, our concentration, our emphasis is only on the decimal part. Now this is the decimal part of a number. Supposing you have 32.856. The decimal part refers to these numbers that comes after the decimal point. This is the decimal point, so this is the decimal part. Decimal part of the number. And remember, this side is called the whole part. We don't deal with the whole parts. We don't deal with the whole part when we are talking about decimal place. So our emphasis only focuses on this part here. Alright, let's take an example so that we'll understand what we're talking about. If we are taking this example and it says approximate 3.062 to 1 decimal place. Now what we're going to do for this number is to bring it out. This is our solution. We'll bring the number out, which is 3.062. When it says to 1 decimal place, it means you are counting just one number after decimal points. It does not matter whether it's 0, whether it's 4, whether it's significant or not, just counts. Alright, so we have this is 1, then we'll take our boundary here. Now what we are rounding off is this very number here, and our answer becomes 3.1. then all this becomes 0 0. Of course they can be discarded because they come after their decimal points, which eventually becomes, remember the sign of your approximation, 3.1. So approximation is not equal to, so you don't always use equal sign to get your answers because you're actually approximating. So you have to know the difference between an equal and an approximation sign. So anytime you approximate, use the sign, not an equal to. Alright, we'll take another example here, and it says approximate 32.556 to 2 decimal places. Let's see, the solution here becomes 32.556. Now what is going to be our rounding off number? First and foremost, since they said to 2 decimal places, you can 2 numbers after decimal point and take your boundary. So this is your rounding off number. Of course, it's large enough to be rounded off to 1. So you have it now as 32.56 as your final answer. Now the last part we will just look at will be the part that refers to the whole number, when you're asked to approximate to the nearest whole number. So we can say approximation to the nearest whole number. Alright, let's see how this is usually done. It is a very simple one. If we're giving an example, say approximate 42.05 to the nearest whole number. My solution here will be very easy. All you just need to do is to round off the number to a whole number, then forget about the decimal. So what that means is that if I have 42.05, my boundary will be taken from this point because I don't need the decimal parts, which means this is the number that I'm rounding off, and becomes, that number is very small, that 0 here is small, so I will discard it and it becomes 42. That is my whole number. So whenever they say to the nearest whole number, they're actually referring to taking your boundary just at the decimal